Before we start, I would like you to tell you that in this particular video, we are going to see what an Azure Load Balancer is, what are its different components, and what are the types of load balancers which we have in Azure Cloud Platform, as well as we will see what are the different SKUs we have. There are two different SKUs available on the Azure platform. We'll discuss about both, and then we will configure one standard load balancer, external or the public facing, for our demonstration purposes. So let's start, guys. First of all, what is a load balancer in Azure? It's an OSI layer 4 device which distributes your incoming traffic to backend pool of resources, and those resources such as virtual machines, containers, etc. And how does it do it? Basically, it takes the help of load balancing rules and the health probes. Load balancers are not used only for distributing incoming traffic, they also can be used for the outbound traffic as well with the help of outgoing rules. Now every load balancer will have four different components, and what are those? First is your front end IP of your load balancer, which is configured when you start configuring your or start setting up your load balancer. Then your backend pool. Your backend pool would be containing your virtual machines, containers, or the network interface card, which would be connected or which would be act as a backend resources for the load balancer. Then your health probes. With the help of health probes, your load balancer monitors the health of your backend resources so that it can find out whether a backend resource is healthy or not, so that it can decide whether to send traffic to that resource or not. And when these three things are in place, you can configure your load balancing rules. Based upon that, it maps the incoming IP and protocol to the backend virtual machines port and protocol. So that's all about the components. Now your load balancers are of two different types, or you can say the Azure has two different types of load balancers. Now one is your public load balancer and the other one is your internal load balancer. Your public load balancer would be external or internet facing, you can see from here, and your internal load balancer would be placed inside a virtual network. Your public load balancer would be able to map the public IP and port of incoming traffic to the private IP and port of your virtual machines, which are in the backend pool here. While your internal load balancer would be receiving traffic from the machines within the Azure virtual network or VPN, and it would be able to send this traffic to the virtual machines in a different tier within the same Azure virtual network. So this would be your internal load balancer. Now these load balancers will come into two different SKUs, and what are those? If you look at it here, when you start configuring, you can see that that time also that's one is internal, one is this is your type of load balancers, and these are the SKUs like basic and standard. Let's quickly see what are the differences between these two SKUs. So first is your backend pool size. Your standard SKU load balancer would be able to support up to 1000 instances, while your basic SKU load balancer would be able to support only up to 100 instances. So if your requirement is up to 100 instances, you can go for the basic one. If it's more than 100 instances, you can use the standard SKU load balancers. Your standard SKU load balancers would be able to support zone redundancy as well as cross zone load balancing, which is not an option in the basic SKU. Then the backend pool endpoints. Your standard SKU load balancer would be able to have any virtual machines in a single virtual network, including blend of virtual machines plus availability set as well as your virtual machine skill set. It can host in your backend pool, while your basic load balancer can have virtual machines in a single availability set or virtual machine scale set. Now the health probes. In the standard SKUs load balancers, you can get three types of health probes, that is TCP, HTTP and HTTP secure, that is HTTPS, while your basic would be able to provide you only two types, that is TCP and HTTP. Talking about security, your standard SKU is secure by default. The public IP, public load balancer endpoints, internal load balancer endpoints, they are by default closed to inbound flows unless you whitelist them with the help of a network security group. While your basic SKU load balancers, all these endpoints are open by default. You can use an NSG, but it's an optional. Then pricing. your basic comes without any pricing. There is no charge for using a basic SKU load balancer, while your standard SKU would be charged based upon the number of rules you configure for the load balancer, as well as the data processed inbound and outbound, which is associated with your resources. So accordingly, you will be paying the cost for this one. SLAs, you will not get any SLAs with the basic SKU load balancers, while with the standard one you will be getting a 99.99% SLA for data path with at least 2 healthy virtual machines in the backend pool. So that's all about the your load balancers available in Azure platform. Now let's configure a load balancer for our demonstration purpose. Before that, let's see what kind of a setup I'm going to use for this demonstration. So what we would be doing, if we already have 2 virtual machines, that's LBVM1 in as availability zone 1 and LBVM2 in availability zone 3. I would be configuring a standard public load balancer which would be external facing. I have already configured these virtual machines as a web server, so these two web servers would be serving that website with the help of this load balancer to the user who is coming from the internet. So let's log into the Azure portal and start configuring it. So this is my Azure portal. If you look at it, let's go to the virtual machines quickly. These are the 2 virtual machines which I was talking about, and you can pay attention here, guys. These 2 machines do not have any public IP address because I'm going to use a standard load balancer, which is a public facing load balancer. So I will be using that front end interface for users to communicate with my backend pool virtual machines. And you can see these are in availability different availability zone. This one is in availability zone 1 and this one is availability zone 3. So let's start creating one. Let's go to home. You can either go to click on that left hand side pan, or you can select from here wherever you want. Click on load balancers, and we already have one, but that's okay. Let's create a new one. Well, let's delete the first one because I do not use it. So let's delete this one. It's getting deleted. In the meantime, we will start creating the other one. And let's click the resource group. Demo 1 would be my resource group. I'll give it a name. Let me call it LB2. This is the location of my load balancer, and you can see here this is the type which you're talking about, internal, and the public one. And if you select internal here, guys, you can see that the options changes. You do not have any options for the public IP assignment. It immediately takes you the virtual network where you can use the internal, or sorry, the private IP addresses for your load balancers. If I select public, I'll get an option to provide public IP address name, and the IP address SKU would be the basic because currently basic has been selected. Now let's see if I change the SKUs, what happens. If I select standard, you can see this public IP address SKU has become standard from the basic, and now I do not have an option to change the IP assignment whether dynamic or static. It is by default static when I'm choosing a standard SKU. Let's look at it again. If I check basic, then I have an option to choose the kind of IP assignment will happen, that is whether dynamic or static. And you can see that the moment I change the load balancer SKUs here, my public IP address SKU changes itself and it matches with the load balancer SKU. So what does it mean? That your load balancer SKU should match with the public IP address SKU which you're gonna attach with the load balancer. As I said, I would be going with the standard one, as Microsoft recommends for all your new designs. You should be going with the standard load balancer as far as possible, because it contains all the features which basic has plus the additional features as we discussed in the presentation part. So let's go and click the standard one. I'm gonna use a create new IP address for this one. Let's call it standard IP1. Okay, this is a SKU standard. I cannot change it. I cannot change the IP assignment, that would stay static. Now let's say availability zone. Now if you want, it can serve a specific zone, but because we wanted to see that it should be able to support our zone redundancy, so this one I'm going to go for the zone redundant. If you want, you can have the zonal load balancer as well, and then you can select on which zone this load balancer would be placed on. Let's go and select zone redundant. I don't want to have a public IP, or sorry, the public IP version 6 address. Let's go to tags. I'm not going to put any tags. Review and create. In the meantime, it will do the final validation. The validation has been passed. Let's click on create. It will start creating the load balancers for us. Okay, my load balancer is ready. Let's go to the resource. So this is the overview which you can see here, that this is the resource group, that the subscription. We currently do not have any backend pool, health probe, and net rules. This is the public IP address which has been assigned with this particular load balancer. Let's start configuring with the components of this load balancer. Front-end IP configuration was configured when we were creating this load balancer. Let's go and click the backend pools. So guys, backend pools would be containing the resources for a load balancer, right? So let's go and click add, and this is where you can specify the virtual machines, containers, etc., whatever you have in the backend pool. So let me give it a name. I'll call it pool 1. Then you need to search the virtual network. This is the network which I'm currently using. Now it will ask me to select the virtual machines which would be the part of my backend pool. So I'll call it, select the LBVM virtual machine first. Then I need to select the IP address, that is the IP address for this particular VM. Let's select the second virtual machines and the IP address for the same. So this is how you create your backend pool. I currently do not have a virtual machine scale set, so it is not being reflected here. As I said, no scale set is found. So let's click on add. So it will validate and add the backend pool for us. So my backend pool is created. Now the next component which I need to configure is health probes. Your health probes allow the load balancer to monitor the status of your applications and dynamically add or remove the virtual machines from the load balancer service. So let's give it a name to my health probe. Let's call it probe 1. And as I said initially, that because we are creating a standard public load balancer, it would be giving us 3 different options to creating health probe, that is TCP, HTTP, and HTTPS. When a probe fails to respond, your load balancer stops sending these new connections to the unhealthy instances. That's what we already discussed. So let's click on HTTP first. So it gives an option to port 80. Basically, your HTTP probe, with the HTTP probe, your load balancer, what it does, it regularly probes your endpoint almost every 15 seconds by default. If your instance is healthy, it responds when HTTP 200 request within the timeout period, and the default timeout period is 31 seconds. You can specify the port here and the URI, the path, and the interval between two health probes and the unhealthy threshold. This unhealthy threshold is important to understand because this is the number of failures that must occur consecutively before your load balancer announce particular resource as unhealthy and will stop sending traffic to it. So let's go it again. This is my name of the probe. This is the protocol which I'm going to use. This is the port. This is the URI path. This is the interval between two different health probes, and this is the unhealthy threshold. That means the consecutive failure. These many consecutive failures should happen before your load balancer announce it as an unhealthy and stop responding traffic to it. If you go and select TCP, let's select TCP. If you select TCP, your TCP probe, it basically depends upon establishing a successful connection, successful TCP session basically to the defined probe port, and which is on a specified listener basically, which exists on your virtual machine. If the probe succeeds, the connection succeeds. If the connection is refused, the probe fails. So that's how you can do. Currently we can use any one of these because we are using a simple web server. So let's go and select this one, click OK. So it will start creating a probe for us. So the probe has been successfully created. Now we can create a load balancing rules, because for creating a load balancing rules, you first need to configure your front-end IP configuration, back-end pools, and health probes. So now we are in a position where we can create a load balancing rules. Let's click click add. Let's give it a name. Let's call it rule 1. This is my front-end IP configuration, which was assigned to it initially. You can choose the protocol, that is TCP or UDP, and your this particular rule will be used or will define how your incoming traffic would be distributed to the backend pool, and this rule will map a given front-end IP and port to a set of backend IP address and port. Okay, so this is my front end IP, this is my front end port, this would be my backend port, and this would be my backend pool. So it has already selected pool 1, which we initially created. This is the pool 1. It gets selected automatically because there's only one pool available, and also selecting the health probe we just created. If we have multiple ones, we can select which one we want for this particular load balancer rule. Now comes the session persistence. If you look at it, there are 3 different options available. One is none, that is the default one basically. And by default, what happens, your Azure Load Balancer, it distributes the network traffic equally among the virtual machines which are there in the backend pool. And it uses a 5-tuple hash to map this traffic to available servers. And what are those 5-tuple hash? That is your server IP, server port, destination IP, destination port, and the protocol. So if we select none, then which is the default behavior, it would be randomly distributed, or your load balancer will equally distribute to the traffic to the backend resources, that is the machines in the backend. If we select client IP here, the client IP, then your load balancer will look for the client IP, and if it finds that the successive requests are coming from the same client IP, client IP address, then it will be handled by the same virtual machine in the backend pool. If you select client IP and protocol here, then your load balancer will check that if the successive request coming from the same client IP and the protocol combination, I mean the IP and protocol both should remain same as the previous connection request, then your load balancer will send this traffic to the previous virtual machine which was handling the connection earlier. So that's how the session persistence defines which would be in the destination backend pool handling the traffic request or the connection request. I'm going to select with none. Then we have idle timeout. Your idle timeout is the TCP or HTTP connection. It stays open and without relying on the keep alives. So after 4 minutes, if there is no keep alive, it will time out and drop the session. While this session is dropped or disconnected, if you select TCP reset enabled, then load balancer would be sending a TCP reset packet to server as well as to the client, informing them that there's a connection is being reset or being dropped. So that gives a consistent approach to your application hosting. Currently we keep it disabled. And then we have a floating IP, that is direct server return, or the DSR. We will keep it disabled. Basically we use it when we start using your SQL always availability on groups, and for this you need to have that your front end port and the back end port should remain same. So then in that case you can use floating IP. And this is something which is recently has been added to create implicit outbound rules. If you have multiple front ends, you can create different outbound rules for your outgoing traffic from the backend virtual machines. If you want to create implicit outbound rules, you can select yes, which is the default. If you don't want, you can select no. I will go with the default one. Let's click OK. Now my load balancer rule is being created and being saved. So you can see that my load balancer rule has been saved now. This is a rule which we just created. Now we can check whether this load balancer can be used. And before we can do that, let's go back to home and go to the public IP address which we just created for this purpose. Let's click on standard IP1, and if you see, if you go to configuration, you can give it a DNS name, which is an optional thing, but you can still give it. I'll call it my LB1. So what you can do to access the web servers which are in the backend pool, either you can use this public IP. I can show you this. Select the public IP and go there, press enter. It should take me to my web servers. See, this is one of the web servers. If I refresh it, this is the web servers working. So now let's go and check this one. I'll copy this one. This time instead of IP, I would try to use the DNS name label. So I'll go there, paste it here, and put it here. My LB1. Click, and this is working. You can see I have got two different web servers. One was configured with a green background and one was configured with a red background. You can see that the web service or the website is being served from both of the servers one by one. So that's all about a load balancer. There is one small thing which I would like to see you before we uh, complete this demonstration. Let's go back to the home, load balancers, and I would like you to have a look at the inbound net rules. Now that inbound net rules you can use from your load balancer's public address to RDP or SSH on a specific virtual machine in the backend pool from outside of Azure. Because if you remember, we have not given any public IP to our virtual machine, so we cannot RDP or cannot log into those virtual machines. For that, we need to use inbound net rules. Let's quickly create one that also. That would complete our demonstration for this one. And let's click on add. Give it a name. Let's call it NAT1. This is my front-end IP configuration. This is the IP version I'm going to use. This is the service. You can basically use a desired service you need. If you want RDP, SSH, whatever you want. In this case, I'm going to do an RDP. So I'll select RDP. The protocol would be TCP. Ideal timeout would default. I'll stay at 4. TCP reset, I'm disabling it, and it has already selected the port 3389 for me and the target of the machine, because the NAT rules, this NAT rule is going to be explicitly attached to a specific virtual machine or the network interface. So to complete the path of this communication, while your load balancer would go and gets attached with the whole backend pool, which is not the case with the NAT. So here we need to select the target virtual machine here. So let's say we call it LBV1. Let's log into the LBV1, and once we select the LBV1, you can select the network IP. That is the private IP for this one. And if you want, you can have a default port mapping, that is your 3389. And if you want, you can make a custom port mapping where you can have a custom port also. Okay, so let's stick with the default. So that would be 3389. Let's click OK. So this inbound NAT rule would be configured for me. Let's wait for some time. So the inbound NAT rule has been saved, so you can see here. Now let's quickly go and see that how to log into this, how to RDP to my virtual machine. I'll open the MSTC console. So let's see RDP. This is my RDP connection. This is the IP which I have. Let's select the IP here, Control C, and go to the RDP. This is the RDP. I will remove all these things. Connect. So you can see it's taking me to the desired server where I'm gonna do the RDP. This was the username if I am correct, and this is my password. Okay, you can see it's going. Is it? I could log into this virtual machine. If you see, you can see the host name also. You can see that LBV1. That was the virtual machine to which we configured this inbound NAT rules. So I'll just disconnect it. So that's it guys, that was the load balancer demonstration. So we have covered, we covered the load balancer definition, its components. We also covered how to create backend pools, health probes, load balancing rules, and the inbound rules. And we also saw in detail what are the components which we need to configure first, and once we are ready with the front-end IP configuration, backend pools, and health probe, then we go and create load balancing rules which would be able to help a load balancer to distribute the incoming traffic to our backend pool machines. So that is guys, that's for it. Thanks for watching.